Okay, this is the error ellipse in 20. So what, again, a reminder, what you're looking at here is trying to look at the 2029 close pass and know whether or not it's going to go through a keyhole. All right? So what you're looking at right now is an error ellipse in 2029 that we know now is about 18,000 kilometers long. However, as time goes on, we're going to get more and more measurements, mostly optical, maybe radar in January of 2013. And gradually that error ellipse is going to get smaller. Therefore, the probability of impact, which is about 1 in 10,000 now, will go higher as the error ellipse gets smaller, so long as the error ellipse still contains the potential impact. In all likelihood, it won't, okay? But what we're looking at is the possibility of, do we have to deflect? All right? So these are numbers out of Steve Chesley at JPL. The compression of the shrinkage of the error ellipse will be a factor of about 4 by mid-2006, a factor of about 10 by 2012, a factor of 100 by about mid-2013. So if you've got a 18,000 kilometer, it'll come down to about 180 kilometers by 2013. 180 kilometers, and you're talking about a target that you're saying, are we going to hit it, that's 600 meters long. Okay? The maximum probability, even if it's headed for the center of the Earth, what you're going to be able to say at best is the probability of hitting the Earth is about 1 in 140. Now the question is, are you going to launch a deflection mission that costs a bunch of bucks if you've got a probability of 1 in 140? You have a lot of people who will tell you correctly that the probability it will miss is 139 out of 140. But you and I right now are saying it's going to hit. But that's the best you're going to be able to say, unless we get better information. All right, well, there's a chance of radar in January of 2013. That would reduce that by a factor of about 4 to maybe something like 45 kilometers. And then you're saying, well, maybe 1 out of 40 or something like that is the probability. Are we going to launch a deflection mission if the probability is 39 out of 40 that it's going to miss us? I don't know. And who's going to make that decision? There's nobody in government who's even looking at it, let alone setting the policy of what the accuracy has to be. Okay? So the problem then is that even using the best optical and radar tracking, the question is, even if it's headed for us, we're going to have a probability that is going to be very difficult to make a decision on. In other words, optical only, about 1 in 180, optical plus radar, about 1 in 40 probability if it's headed for the center of the Earth, if it's headed for us. And if, on the other hand, we put a transponder on the asteroid before 2012, then we'll have information which will give us a probability of impact of about 1 in 10. Now, I would suggest a 1 in 10 chance that you're going to have a $400+ billion consequence if this thing hits the Earth is probably justification adequate to decide to go ahead and launch. But without the transponder, I suggest we're not going to have the adequate information. So I'm going to bypass this so that we can get to the end. But let me just tell you, the problem here is that no one in U.S. government today is charged with the responsibility of doing this kind of an analysis, of looking at the issues of deflection, at coordinating internationally the policies. Let me tell you, as soon as you attempt a deflection, you have transformed an act of God, an asteroid hitting the Earth somewhere, to an act of humankind because you've started to move that asteroid. And it doesn't just move randomly, it actually moves one way or the other along that same path until it's off the Earth. Now the question is, if you move it away from the California coast but put it over Guatemala by accident, you know, or how about moving it the other way and it lands in north of Hokkaido and you wipe out Tokyo? So there are many, many policy issues related to the fundamental decision making for somebody who's got to have in their head, my job, and I'm held responsible for it, is to think about, do we or do we not need to deflect an asteroid? And how do we do it? What are the policies, etc.? That's the issue, and today there's no agency in government. Therefore, I'm calling on the Congress of the United States to do two things. Number one, to check what I've just told you here. I've done as good as I can, but I don't have a Monte Carlo sized computer that I can start doing all kinds of fancy stuff with. I have to make approximations based on the best data I can get. But they are approximations. Okay, so number one, it's got to be checked. Number two, we've got to have somebody in government who's responsible, not just as NASA is now, for looking for these things and putting them in a database, but for actually being responsible for the decision making and all of the assorted things related to it associated with potential impact of these things on the Earth. Now, I hasten to say again, we're talking a 1 in 10,000 probability. There's not a reason in the world for anybody to lose any sleep about this, okay? Unless you're assigned the responsibility for protecting the Earth. Then you ought to be staying awake a bit. Okay, thank you very much.